As our last exploration of substitution integrals, we consider some cases, or a case in specific here, where we don't have that nice something and its derivative pattern, at least not obviously. Now we'll see how that works out in this example here. Here there's just one root x running around. There's no 1 over root x to cancel it if we were to choose it as our substitution. But it's also clear that we can't find an easy antiderivative for this. The temptation might be to say, oh, ln of absolute value of root x plus 1. And that would be wrong, quite frankly. Why would it be wrong is a better question. The reason is that if we differentiate this, if we try to check and take the derivative, we would get 1 over root x plus 1, completely agree, but then we would also get the derivative of the inside, and the derivative of the inside would be 1 over 2 and another root x, and we don't want any of this stuff. We just want this. And there's not going to be a way to tweak our ln to make this go away. We'll end up with product rules and end up getting more and more complicated antiderivative ideas that are not going to work out. So just remember, this ln rule only works when you have a nice x or maybe a coefficient out front of it. It certainly does not work for powers of x or roots of x in the denominator. Okay, so strategy. We look at it, we look for any obvious antiderivative. We can't find one. So maybe a substitution would help. Let's try something. If in doubt, put something on the page and see what happens. There's really only two obvious substitutions. One would be root x or root x plus 1. Usually it's easier to include the whole thing, the whole inside function, in this case the whole denominator, to see what happens. If we let w equal root x, we get dw over dx is 1/2 1 over root x. So 2 root x dw equals dx. All right. So that would be our substitution. We'll see what happens. Our integral of 1 over root x plus 1 then gets converted to an integral of 1 over w, which is fine. But then the dx part gets converted to a 2 root x dw. And here's where we hit our difficulty. We didn't cancel the x's. So we ask our question, are there no x's? And we have to answer, unfortunately, that we're not there yet. There are still some x's left. Okay, what can we do? Well, in this particular case, we can actually convert that 1 root x into a w. Let's see how that would work. That root x plus 1 is w, so root x is equal to w, bring the 1 over, minus 1. So that new root x that just appeared can be removed by using that root x equals w minus 1 relationship. So we have 1 over w, I'll bring the 2 out front, and the root x is a w minus 1, and then a dw. Okay, now we're in business, because we can rewrite that a bit more nicely as the integral 2 times w over w is 1, minus 1 over w, that's fine, dw. Now each of these can be integrated. So even though the substitution we chose may or may not have worked, it depends on the form of the integral, it was worth a try to explore though. It does eventually give us a new integral that's simpler and that has no x's. So simpler, check. And no x's now, absolutely. So we're going to end up with 2. The integral of 1 dw is w. Now we get a ln of w here, absolute value. And then we just go back to x's. 2 w is root x plus 1. So we get a root x plus 1 minus the ln of the absolute value of root x plus 1. And if you wanted, you could note that root x is positive, 1's positive. We don't need the absolute values here. It doesn't do any harm to leave them in. And what did we forget? What did I forget? Plus c. There we go. This is an indefinite integral, so we need the plus c at the end. And there is our indefinite integral of 1 over root x plus 1.